Simultaneous equations is all about the solving of two equations together. Sometimes it's also about solving three linear equations together, but you don't have to worry about that for some time. What does it mean to solve two equations together? That means when I have two of these lovely equations, where basically there is a value for x and a value for y that are the same in both. So the y here is going to be the same value here, and the x here is the same value here. In other words, one number minus 3 times the second number is equal to 2 is the same as that second number minus the first number is equal to 2 also. We've been given a lovely bit of a graph, as we can see here. Now, I have forgotten to label because I am a chump. That is the graph x minus y equals 2. This is y minus 3x equals 2. The easiest way to determine what the value of x and y are in order for those two equations to be equal to each other is to graph them, because the point where those two lines meet is exactly where what values would go and be equal to these two equations. So what do I mean? So unfortunately the little diagram that I've drawn here is a bit not very particularly accurate, but if you happen to have a look on the original textbook question, which is 4.2 question 1e, which I conveniently did not make as one of the questions, you'll notice here that this is actually a -4. So the actual point that they meet is at the coordinates -2, -4. Or in other words, the solution to these equations are x equals -2, y equals -4. So in other words, for these two equations to be equal to each other, x needs to be -2 and y equals to -4. Now, does that make sense? Well, let's go and prove it, because I am of the habit of suggesting that you shouldn't just listen to me saying something rubbish about lines and where do these lines meet and so on. Well, let's go and substitute. So what I mean by substitute is I'm going to prove to see if x is equal to -2, if y equals -4, then our two values should be equal to each other. So let's go and see. So I'm going to substitute. Now, I'm just going to, for convenience, I'm going to just label this is equation 1, and this is equation 2. And what I'm going to do is I'm going to sub x equals, we can see there, x equals -2 and y equals -4 into equation 1. So let's see, so this should be a thing here. So x is, so -4 minus 3 brackets -2 is equal to 2. -4 plus 6 is equal to 2. -4 plus 6, 2 is equal to 2. So that works. Excellent. And if I substitute x equals -2 and y equals -4 into, let's get my color coding right, into 2. So this will be -2 minus -4 is equal to 2. -2 plus 4 is equal to 2. Well, yes, 2 is equal to 2. Therefore, we have solved this question. Hooray! Go us! So, now, substitution is one of the methods of solving simultaneous equations. In other words, if I was to substitute a particular letter for a number, or a particular pronumeral, should use my fancy words, for a number, and I substitute the other pronumeral for a number in both of those equations, they should equal each other. So let's go and have a look at question 2, just to demonstrate what it is that I'm rambling about. So question 2 of exercise 4.2 is all about asking if I substitute these coordinates into these equations, will they be the same? So what I'm going to do here is I'm going to substitute, and again I'm going to label these I like to color code, not just because it's pretty, but also I remember which one's which. Sub x equals, now the coordinates, that 4 means that x equals 4, and this is y equals -3. Oh no, I shouldn't muck up my color coding. Oh, just ruined everything. Can't math now. X equals 4, y equals -3 into 1. So let's go and see what this results in. Okay. So we'll get -3 is equal to 3 times by 4 minus 15. -3 is equal to 12 minus 15. -3 is indeed equal to -3. Huzzah! So that works. Let's see if it works for the second one as well. So I'm going to sub x equals 4, y equals -3 into 2. And I'm going to get, I'm going to get 5 times by 4. Take away 2 times by -3 equals 43. Let's go and see. 5 times 4 is equal to 20. -2 multiplied by -3 is going to make that +6 equals 43. And wait a minute. 26 does not equal to 43. No. So this is, by substituting here, I can tell you that these two equations are not equal to each other, or they do not equate. So, bow. This set of solutions, or this coordinate, will not be the set of solutions for both of these equations. But how can you actually determine, so does that mean that there is no possible answer for this set of equations? Well, I don't like to say never say die at all. Let's go and find out if there is actually a set of coordinates that will be able to fit in both. So let's just write down on my new piece of paper here, courtesy of New Pieces of Paper Proprietary Limited. Let's go and see here. I shall go and get myself a pen. Let's go and see here. Oh, there we go. Let's use this red pen. So the two equations were y equals 3x minus 15. Can we see that up there? Oh, yes, we can. So 5x minus 2y is equal to 43. So we want to see if these two equations will match up. Now, one of the methods that we're talking about is substitution. So another way of solving this, you'll notice here that it says here y is equal to 3x minus 15. In other words, whenever I see a y, I could replace it with this entire expression and solve accordingly. What do I mean? Well, I'll show you. I'm going to sub equation 1 into equation 2. So what this now looks like is I got 5x minus 2, brackets, 3x minus 15. So I've just replaced every time I see a y with this friend here. So, let's go and see. Minus 6x. -2 times by -15 is going to make that positive 30. 5x take away 6x is just -x plus 30 is equal to 43, or minus 30 from both sides. -x is equal to 13. X is equal to -13. Great. So now what I'm going to, so I now know that when the coordinates, when x is equal to -13, that means that these two equations will be equal to each other. So, and then we've got our next one here. So we'll have so we'll go, so we need to find a y coordinate as well. So what I'm going to do is I'm just going to sub x equals to -13 into equation 1. Y is equal to 3 times -13 minus 15 3 times negative 13 is going to be negative 39 minus 15. Negative 39 minus 14, well, negative 40 minus 15 is going to be negative 55, so it's going to be negative 54. That sounds like a thing. Say it with confidence, and it's true. So therefore, the solution is negative 13 to negative 54, or when x is negative 13, y is equal to negative 54. So, prove it. Oh, I should also make sure. Prove it. Now, what I'm about to do is purely optional. You don't have to prove it, but as I've often said, don't always believe the loudest voice in the room. Let's go and make sure to see if this works. So I'm going to sub x equals negative 13, y equals negative 54 into equation 2. Spoiler alert, we're going to get some big numbers. So this is going to be 5, negative 13, minus 2, negative 54, is equal to 43. So 5 times negative 13, well, that's going to be negative 65, because 5 times 12 is 60, so therefore 5 times 13 will be 65. Negative 2 times by negative 54 is going to be positive 108. Negative 65 plus 108, well, that would be the same as saying 108 take away 65. 8 take away 5 is 3. 10 take away 6 is 4. And huzzah! We have thus demonstrated that that is indeed correct, and we can have a big smiley face. Or maybe just an average size one. We don't want to get too carried away. So now that's solving by substitution.